In this video, I'm going to explain a little bit about slide calipers and using these how we can measure something. So this is the simplified figure, I guess, that I've drawn here in this whiteboard showing the slide calipers. If you look closely, that this is the main scale and there are two jaws, which is external and internal jaws. So these jaws are actually movable. They can actually slide from one side to another side, and there is a screw. So using this, we can move it from the right side to the left side. And there is a space in between these two jaws, because when we need to measure something, we have to place these things in between these two jaws. Actually, we can use both the jaws in different aspects. But before going to explain all these, we need to know that the process or the theory that how we can actually measure things through the slide calipers. Before going to explain, the main thing is that when we will measure the length, the principle is we need to find first main scale reading. This is important. I'm coming up with this theory. Plus Vernier Constant or Vernier Coincidence. Vernier Coincidence. Then gonna multiply with Vernier Constant, and then we have to subtract from the mechanical errors. Theoretically, we will follow these lines, and we need to know very simply that what is main scale reading, what is Vernier coincidence, and then what is Vernier constant, and what is the mechanical errors. So, as we know that in physics, when we study measurement, we need to know how to use slide calipers, how to use screw gauge, and the theory in it. Now think about this one. These two jaws, which are external jaws, we use it to measure the external diameter of anything. Suppose this is a marker. I need to find the diameter of this marker. So we will place these two jaws, which external jaws, in between this marker, and then it will give us the reading, the way of reading to find out the diameter of this marker. But if I want to find the internal diameter of this cap, then what I need to do, I need to put these two jaws, internal jaws, internally, and then attach it to the upper side of the lower case of this cap, so that I can find the internal diameter. So usually these two and these two, you see the directions are different. So when we will use things to measure external diameter, we will use this one. Let's think that something is placed here in between these two external jaws. Before going to explain, we need to know one more thing, that there is two different scales, the main scale and then adjacent or movable Vernier scale. And as it is going sliding, we can use it through sliding. That is why it's called slide calipers. Now, what important thing is that in this slide Vernier scale, there are 20 space. So if it is 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. But I got till 15, but it would be 20. So this 20 is the marking for Vernier scale, but that is equivalent to the 19 space of main scale. 19 space of main scale. So if this is the main scale, I can show you simply that the 20th, this should be the 19th, and this should be the 20th. I mean, if it is 0, then this should be the 20th. So it should be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. It means that here this is the 20th space of the Vernier scale, which is equivalent to the 19th space of the main scale. As it is main scale and this is Vernier scale, there is a slight differences in between the spaces of main scale and Vernier scale, and this difference is known as Vernier constant. Let me clear one thing. This is Vernier, this is the main scale, and you know it's given in millimeter unit. Millimeter unit. So this is 1 millimeter. So if I draw the main scale reading here, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 0 to 10 millimeter. So from 0 to 10 millimeter, that is completely 1 centimeter. I'm making it bigger to show you that this 10 millimeter is actually 1 centimeter. So all the space is actually 1 millimeter. Now in main scale, you know that the smallest space is 1 millimeter. And now you've got that Vernier scale 20 space. Vernier scale 20 space is equal to main scale 19 space. You see that the 19th mark of the main scale is equivalent to the Vernier scale 20. So as you know that main scale space is 1 millimeter, so in total 19 space would be 19 millimeter. So we can say that Vernier scale 20 space is equal to 19 millimeter. So Vernier scale 1 space is equal to 19 by 20 millimeter. That is actually 0.95 millimeter. So what we got, that this main scale space, 1 space, is bigger than the Vernier scale space. So simply the differences in between these two spaces is the Vernier constant. So simply we can say that Vernier constant is the main scale 1 space minus Vernier scale 1 space. So the main scale is 1 millimeter, as we know that 19 is 19 millimeter. So main scale is 1 millimeter, and we got the Vernier scale 1 space is 0.95 millimeter. So if I subtract 0.95 millimeter, we will find the Vernier constant is 0.05 millimeter. So when we will measure something through the slide calipers, we need to understand first, we need to fix it first, that what is the Vernier constant of that machine or of that instrument. So as it is measuring instrument, it should be accurate. So usually the Vernier constant is 0.05 millimeter. Okay, so this is the way we actually find the Vernier constant. So what is Vernier constant? Vernier constant is the differences between one smallest space between main scale and the Vernier scale. In other cases, we also can find the Vernier constant by using a simple formula, which is Vernier constant is S divided by M. What does it mean? S is the length or the magnitude of the smallest space of main scale reading. So main scale, the smallest main scale, smallest gap divided by the number of space in main scale. So N for the number of space in Vernier scale. So S by N, as we know that S, that means the smallest distance to space in main scale is 1 millimeter, and the number of space in Vernier scale is 20. So if I divide 1 by 20, you will find 0.05 millimeter, which is the Vernier constant. So if we know the smallest distance of main scale and Vernier scale, we can find the Vernier constant, and also we can easily find the Vernier constant by dividing S by N. So the number of space in Vernier scale 20, and the smallest distance of the main scale is 1 millimeter. So 1 millimeter by 20 is 0.05 millimeter is the Vernier constant. So now how we will measure and how we will find the length using this Vernier scale. Let's concentrate something. Let's concentrate on the Vernier scale and the main scale. Suppose now I draw it reversibly. This is the main scale. This is main scale. Here this is 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Suppose I'm just taking 10th of the main scale. Now this is main scale. Okay. This is main scale, and this is Vernier scale. And Vernier scale, after placing the things in between these two jaws, the Vernier 0 has shifted here. So that is actually 0, 1, 2, 3, 4, 5, 6, 7. Think about it. So as you know that when you placed something in between these external jaws, now you see this is the 0 of main scale and this is the 0 of Vernier scale. So the 0 of Vernier scale has shifted after the number 5 number space. So we have to count that at least which space it crossed. Suppose this is the 0. According to this figure, 1, 2, 3, 4, 5, 6, 7, 8, 9. It crossed number 9 of the main scale. If I say this one, number 9 of the main scale, then main scale reading is 9 millimeter. Okay, now you find the Vernier coincidence. What is Vernier coincidence? When we placed something in between these two external jaws, we need to find that which mark has the right vertical alignment with a single line of main scale. Think about this. Here this is 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is 1, 2, 3, 4, 5, 6, 7. Now you see this, I'm just showing you a reverse. So this is the Vernier scale and this is main scale. So number 1, number 2, number 3, number 4, they are not aligned with the mark of main scale. But you see that number 5 and number 9, they are aligned like this is number 5 and this is number 9. So through your eyes you can see they are vertically aligned. So number 5 is the Vernier coincidence. So when we will place anything in between these external jaws, we need to find that which mark is vertically aligned with the main scale. Then we will find that mark from the Vernier scale, not the main scale. So the Vernier scale 5 is aligned with the main scale 9. So the Vernier coincidence is 5. And you got the Vernier constant of this 0.05 millimeter. And now what is the errors? The errors are when these two jaws are aligned together, when they will actually close together, then it should be that vernier 0 and the main scale 0 will vertically aligned. So again, this 0 is for main scale and this 0 is for vernier scale. But if the 0 of vernier scale kept left behind this 0, or it can be here, I mean it crosses the right side, or it can be in the left side. So if it is in the right side, that means the 0 of vernier can't reach to the 0 of main scale. In this case, the error should be negative. But if the 0 of vernier crosses the 0 of main scale, then these errors are positive. So here the sign plus minus error, it means that if the 0 of vernier scale can't reach till the 0 of main scale, it should be negative. And if it is negative, then ultimately it should be the positive, because this is minus. If you multiply minus and minus, we'll find positive. But if the positive errors are there, then if we use positive, it would be ultimately negative. So we will use the errors based on the positions of the zeros of main scale and the vernier scale. So my standard is main scale. If main scale 0 is reached by the vernier scale 0, then it is okay. But usually what is the main scenario? When zeros are aligning together, they're actually vertically aligned together, then we say this is no mechanical errors. Hopefully we wish there is no mechanical errors. So there is no mechanical errors are there. So usually what we can say this is 9 millimeter and this is 0.25 millimeter, and we get that the length or the diameter of this plus thing is 9.25 millimeter. So usually how we will draw it and how we can use it in laboratories and then find some sort of like writing part of your practical books, then you might need to build a table. In this table you need to draw something like this is first one, the second one and the third one. You might need to take the length for 3 times and then you can find the mean. So number 1, you can find the main scale reading. Number 2, you can find the Vernier Coincidence and then Vernier Constant, and then you can multiply. You can find the mechanical errors, and then this is the summations. How? Think about this is main scale reading. You find it, and then you find Vernier Coincidence, and you got Vernier Constant. So Vernier Constant is actually the fixed, that is not changed. So in this point we will use that Vernier Coincidence times Vernier Constant, and then the next part we'll find the mechanical errors, and this part would be the main things, or we can actually diminish this one. We can use that M plus V times VC minus plus minus errors. So when you find these values, we will use it several times. Suppose we are measuring length, then we have to measure 3 times. If we are measuring breadth, we have to find it 3 times, and then arithmetic mean. So suppose the main scale reading is if you got 7, if you got 8, the Vernier Coincidence in times you got 9 or even just 5, and then you can find the Vernier Coincidence and VC, that is 0.05 times 9, 0.05 times 5, and then if there is any sort of mechanical error, use it and then find the value. And when you find a value for 3 times, we can get the arithmetic mean of the length. So this is the simplified figure of Vernier slide calipers actually. And this is slide calipers because we can use it and can slide it from right to left based on the main scale. And we can use this table. Before going to explain this, you need to definitely find the meaning of these things. Length is equal to main scale reading times plus Vernier coincidence, and then times Vernier constant, then the plus minus E or mechanical error. Before using this mathematically, you must know the principles how we can find the area, the volumes and some other things. Suppose if there is a round shape, things is given to find the diameter of things, and then it's saying that to find the volume of it, then volume is 4 by 3 pi r cube. We know that is diameter, so r is d by 2. So we can say that 4 by 3 d by 2 whole cube. So it can be 4 by 3 pi d cube 8. So that is, we can say 1 by 6 pi d cube. So if we try to find the volume of any circle, then we can find the radius or the diameter, and then using this principle we can find the volume of the diameter. Even in case of finding the rectangle, we can find the length times breadth times height. But we must be clear about centimeter and millimeter. Centimeter and millimeter. If centimeter is given, suppose 7 centimeter, in case of finding millimeter, it should be 70 millimeter. If there is given 7 millimeter and to find it to centimeter, it will be 0.7 centimeter. So when we will go from centimeter to millimeter, we need to multiply by 10. And reversibly, if you go to millimeter to centimeter, we need to divide it by 10. So these simple things we should consider when we do the measurement, and definitely using these materials requires much more attentions and seriousness. When we will use it in our laboratory, we will try our level best not to make any harm of it, and we can use it accurately and successfully, because these machines are very important, and this sort of instrument are really worthy for us, so that our juniors also can use it. So whenever a group of students are using these materials in their lab, they must be much more careful and they should be serious about measuring things. And of course, when we measure this slide calipers, we should understand the meaning of these 4 important topics. So I'm coming up with screw gauge uses and some sort of idea regarding the screw gauge use, and with some example of real screw gauge, and I can show you that. So take care, see you in the next part.